Good afternoon, students. So far, we have seen about the structure of the atom. In structure of the atom, we have seen about the introduction to the atom. An atom is the smallest particle. We will rush up the introduction part. Um, an atom is the smallest particle of a chemical element possessing the chemical properties of an element. Okay, it was first model was designed by J.J. Thomson. In his model, he explained the atom as a sphere size of 10 power minus 10 meter and has a positively charged in which electrons were embedded. But this comes as a drawback for the J.J. Thomson model when he done his experimental part. Then next is a Rutherford experiments of scattering of alpha particles. He confirmed that yes, there are some undeflected particles was explained due to the fact of the atom where it is empty all around the nucleus. That is, nucleus is at the presence at the center, and around this there is an empty place, and these electrons are revolving around the nucleus. So due to this, there is an undeflected alpha particles comes from the alpha ray scattering of particles. This was first found by Rutherford. Later, Rutherford found his model, and which is have some of the drawbacks. It was overcome by the Sommerfeld and Bohr's. So from the Bohr's theory, we cannot able to explain that. It's able to explain only the series spectra of the simplest hydrogen atoms. When we move to the complex alkali metals, these Bohr atom model and Sommerfeld atom model could not able to explain this. But Rutherford has some of the drawbacks, and these drawbacks has been overcome by Bohr's theory and Sommerfeld theory. But even though we have many positive points in Bohr's theory and Sommerfeld, but small drawbacks is they cannot explain the series of serial spectra of alkaline materials. The fine structure of spectral lines can be explained through the vector atom model. A new model which is derived after this Bohr's theory and Sommerfeld theory was first derived by Vector, and his model is called as vector atom model. Before that, we cannot able to explain the intensities of these spectral lines. We are saying that from according to the Bohr's theory, we can say that Balmer series, Lyman series, all these series, but with this series we cannot able to explain the relativistic intensities of these lines, spectral lines. Then, according to the vector atom model, we can see the two concepts has been introduced in the vector atom model. The first one is conception of spatial quantization, and the second one is spinning electron hypothesis. Spinning electron hypothesis. So what about the spatial quantization? What about the spatial quantization? It is nothing but the orbits are quantized and with their magnitude. That the direction or orientation of the orbit in space is also be quantized. So we can say a spatial quantization, that is, we can explain this in three spatial coordinates x, y and z axis. When we are explaining this, their magnitude are fully quantized along with their direction. To explain this, we need a reference axis. We have fixed the reference axis. This reference is decided by the direction of the applied external magnetic field. So we can say in which direction x should be there, y and z axis has been fixed by means of an external magnetic field. And this projection of this quantized orbits of the field direction which gives the vector atom model. This is called as spatial quantization. And the second one is spinning electron hypothesis. What about this? This was first found by Helmberg and Goldsmith in 1926. Here they explained that these electrons are revolving around the nucleus has a spin about its axis of its own, while it also moves around the nucleus. When it is moving around the nucleus, first it will rotate itself in a spin like, and then it will rotate around the nucleus. So spinning and then it is rotation, spinning and then it is rotation around the nucleus. Okay. So along with this orbital motion, electron is ended with the spin motion, orbital spin, orbital spin. So we have both. So here also both this magnitude and direction are quantized. Okay, this was explained by as a quantized vectors. Then he found that vector atom model, Vector found that quantum numbers associated with this model. Okay, what are all they? We have 7 quantum numbers. The first one is principal quantum number n, then orbital quantum number L, spin quantum number S, total angular quantum number J, and magnetic orbital quantum number ML, magnetic spin quantum number MS, and then magnetic total angular momentum number Mj. Okay. First, initially we have only the 4 principal quantum number, orbital quantum number, then total angular momentum quantum number. Later, after this vector atom model introduction, we have all these 7 atom model numbers, quantum numbers associated with this model. So what about this principal quantum number? N denotes that this is a series number of shells starts from the innermost. We have the nucleus at the center and around which where electrons are revolving around the nucleus. So we have different types of shells. We have different layers of shells and we have to count the number of shells from the innermost orbit. That is called as a principal quantum number n. It takes only the integral values excluding 0. It starts from 1, 2, 3. The second one is orbital quantum number. It is denoted by L, where it takes, for example, it takes the value L is equal to 0, 1, 2, 3 up to n minus 1. For example, if we consider n is equal to 3, n is equal to 3, so totally we have 3 shells around the nucleus and it takes the value, L takes the value of 0, 1, 2 because n minus 1. So 3 minus 1, 2. So the number up to 2, 0, 1, 2. Okay. We can say if L is equal to 0, if n is equal to 3, then if L is equal to 0, then it is called S electron. L is equal to 1, it is called P electron. L is equal to 2, it is D electron. L is equal to 3, it is F electron. By classical mechanics, the momentum is expressed as P and is denoted by PL will be equal to L into L plus H whole power half into H cross. The third one is spin quantum number. It is S. S is spin, that is one is positive spin, another one is negative spin. Okay, for every L we have 2 different spin. Then total angular quantum number J is equal to L plus or minus S. Okay. So for example, we have considered n is equal to 4, then we have n minus 1 of L. So L is equal to 0, 1, 2, 3. S is equal to plus half minus half. First we take L is equal to, for L is equal to 3 we can take. So J is equal to L plus S. J is equal to L is 3 plus half, which is half, J is equal to 7 by 2. If S is minus half, then we have J is total angular momentum is 5 by 2. If n is equal to 1, L is equal to 0, then we have along with that we have plus half and minus half. So totally J angular momentum with positive spin J is equal to 1 by 2. With the negative spin J is equal to minus half. So it will goes like this. So it depends on J, depends on both L and S. L depends on n. Then next one is magnetic orbital quantum number. We are saying that magnitude has a size and form and it is have a projectile motion with quantized numbers. With quantized numbers, we can able to give the projections for all the things. For example, the possible values ML has a values of L, L minus 1, L minus 2, L minus 3. So we have the formula has 2L plus 1. For example, we are taking L is equal to 3. That means N is equal to 4. L is equal to 3. The permitted orientations are 1 of L are, the permitted orientation of L are 7. How? So already we have seen if L is equal to 3, we have 7 by 2 or 5 by 2. Okay, so we can see 7 by 7 values. So 2L plus 1, if L is equal to 3, 3 into 2, 6 plus 1, it is equal to 7. So ML will be equal to, from starting from 3 2 minus 3 to plus 3. So 1, 2, 3, 4, 5, 6, 7. So this is the projection. Without spin, we are giving the projection. So this is ML equal to 0, 1, 2, then 3. Okay, again it is minus 1, 0, then minus 1, minus 2, minus 3. L cannot be inclined to B at any other angle. This is called as a spatial quantization. Then the last we can see, then we can see about the magnetic total angular quantum number. Okay. The same 7 we have already seen. When L is equal to 3, it is plus half, it is 7 by 2, and it is minus half, it is 5 by 2. So from this excluding 0, we have this value as 2j plus 1. I have the formula as 2j plus 1. For L is equal to 1, j is equal to L plus S. So we can say j is equal to 1 plus 1 by 2, that is 3 by 2, then j is equal to half. Then what about this mj? Mj is equal to 2j plus 1. So if j is 3 by 2, then 2 into 3 by 2, 2 will be cancelled. So 3 plus 1, it have 4 values. It has 4 values. So what are the 4 values? So start from minus 3 by 2 to minus 1 by 2, then again plus 1 by 2, then 3 by 2. So these are the possible values in the 7 magnetic total angular quantum number. So these are the 7 quantum numbers. With all this vector atom model, Pauli's exclusion principle has been started. So what about his statements? No 2 electrons in atom exist in the same quantum number. This elaborately can be seen in the next class. Thank you, students.